Hi, this is Alexandros with alexandros.io, and today we'll be working through LeetCode 238, Product of Array Except Self. This is a coding interview question that has appeared in interviews for companies such as Amazon, Meta, and Microsoft. The problem asks, given an array of integers called nums, return an array whose ith element is the product of all the elements in the nums array, excluding the element at index I. Furthermore, the algorithm must solve the problem in O(n) time, and we are prohibited from using the division operator. Given this array as an example, we would return an array whose first element is 24, as 2 times 3 times 4 is 24. The second element will be the result of 1 times 3 times 4, which is 12. The third element will be the result of 1 times 2 times 4, which is 8. And the last element in the array will be the result of 1 times 2 times 3, which is 6. The intuition that leads us to the solution in this problem is that the product except self for the ith element in the nums array is equal to the product of the elements to its left and the elements to its right. For example, the product except self for the second element in this array will be the product of the elements to its left, which is 1, times the product of the elements to its right, which is 12. Since 1 times 12 equals 12, this will be the value at the second element of the output array. Similarly, the product except self for the third element in this array will be 2 times 4, which equals 8. We can use this intuition to solve our problem by utilizing two additional arrays, whose ith element will hold the product of the elements to the left and to the right of the ith element in the input array, respectively. Let's see this approach in action. We'll start by building out the left product array by iterating through the nums array. We'll start by taking the first element 1, and since this has no elements to its left, we'll set its left product value to 1. We'll then take 2 and we'll calculate its left product. This will be equal to the product of the preceding element in the nums array and its corresponding left product, which is the rightmost element in the left product array. In this case, both are 1, and so we'll calculate the second element's left product to be 1. After that, we'll take 3 and we'll multiply 2 and 1 to get its left product. Finally, we'll take the last element in the array, whose value is 4, and we'll multiply 3 times 2 and get 6 for its left product. Now that we have the left product array, we'll carry out a similar process to build out the right product array, with the difference being that we will start from the rightmost element of the nums array and work our way to its leftmost element. We'll start by taking 4, and since it has no elements to its right, we'll set its right product to be 1. After that, we'll take 3 and calculate its right product. This will be the product of the elements to its right, which in this case is 4, and its own right product, which we calculated in the previous step, to be 1. 4 times 1 is 4, so 3's right product is equal to 4. We'll then take 2 and multiply 3 times 4 to get its right product, which is 12. Lastly, we'll take 1 and multiply 2 times 12 to find its right product, which equals to 24. At this point, we have the left product and right product arrays ready, and we need to build the array which will contain our answer. In order to build the answer array, we need to go over the left product and right product arrays at the same time and calculate the product of each corresponding element. For example, the product of their respective first elements is 24, the product of their second elements is 12, the third elements have a product of 8, and their last elements have a product of 6. After this step, we can now return the answer array and be done. In this approach, we went over the input array twice, once for building the left product array, and once more to build the right product array. After that, we went over those two arrays once at the same time to build the answers array. Given the left and right product arrays will be the same size as the input array, the time complexity will be O of 3n, which simplifies to O of n. The space complexity of this approach will be O of n, as our algorithm required additional arrays of length n. While this approach is pretty good, a follow-up to this question is whether we can solve this in constant space, given that the output array will not count as extra space for our space complexity analysis. A way to satisfy this requirement is by, instead of using the left and right product arrays, we can use the answer array to store intermediate calculation results. Similar to the previous approach, we'll solve this problem in two passes over the nums array, one pass from left to right and a pass from right to left. The left to right pass will be identical to our previous approach, with the difference that instead of storing the result in the left product array, we'll store the result in the answer array. Once our left to right pass is complete, the answer array will contain the left product for each element, and now we have to start our right to left pass. Before we do so, however, we need to introduce a new variable that will hold the product of the elements we've seen so far as we iterate the array from right to left, and we'll initialize this to 1. The introduction of this variable is necessary because the answer array already contains values that we added from our left to right pass, and so we can't use the values therein to find an element's right product and use it in our calculations. We'll start by taking 4. We see that the right product is 1, and that its left product, which we calculated in the left to right pass, is equal to 6. Thus, its product except self will be equal to 6. Once we set this value in the answer array, we'll also update the right product variable to be 4. In the next step, we'll take 3 and we'll multiply the right product 4 with the left product 2 and get 8. Furthermore, we'll update the right product to be 4 times 3, which equals to 12. Then, we'll take 2 and we'll multiply its right product 12 with its left product, which is 1, and we'll get 12. Again, we'll update the right product variable by multiplying 12 times 2, which equals 24. Lastly, we'll take the first element in the nums array, which is 1, and multiply its right product with its left product to get 24. At this point, having finished both the left to right pass and right to left pass, we have successfully built the answer array and we are done. The time complexity of this approach remains O of n, as we had to go over the input array twice. Since we did not use an additional data structure other than the answer array, which we were told is not included in the space complexity analysis, the space complexity of our solution will be O of 1, or constant. Let's now see a Python code solution to this problem. We'll start by initializing our answer array and setting the first element to 1, as the first element of the input array has no elements to its left. Then, we'll start iterating the input array and calculate the left product for each element. Before our right to left pass, we will initialize a variable that will hold the right product as we iterate the input array. We'll then enter our right to left pass and set the answer at index I by multiplying the right product, which is held by our variable, with the left product, which is the ith element currently in the answer array. We'll then update our right product variable to be used in subsequent steps. Finally, once we finish with the right to left pass as well, we can return the answer array and we are done. Now that you know how to approach this problem, try coding up the solution by yourself and try coming up with other algorithms that solve this. If you have any feedback for this video, please leave a comment down below and don't forget to like and subscribe if you want to see more of these. Thank you for watching. This has been Alexandros with alexandros.io.